All right, so good morning, everyone. Thank you for attending the first session of the day. I was not expecting that many people. Maybe it's due to the fact that we have an amazing title generated by ChatGPT today. Anyways, for those who don't know me, my name is Bastien Claeys. This is my first NOG, and I'm regional PLM at Nokia for the data center solution. And together with me, for the next 25 minutes, you are going to discover or rediscover an amazing tool that can drastically change the way you use and perceive network labs. So network labs, let's talk about it. I think a lot of people in this room need network labs just as much as we do in the vendor side. And you need them for multiple reasons. Sometimes simply because you want to introduce a new change in your network. So you want to make sure that this change is not going to cause more issues than it brings solutions. Maybe you want to prototype a new topology, you want to create a new network, or maybe for a more simple reason, you just want to have a lab to try new things, to learn new technologies, to try quick in your data center fabric, who knows. So you have many different reasons for using network labs. And nowadays, how do people use network labs? Well, you have multiple options. If you're really, really lucky, maybe you will have a physical lab that you can use. That's the expensive way of doing things, but if you can do that, that's very useful. But obviously, most people, like you and I, are going to use virtual environments. So when you create virtual environments, you need to define every single item in this topology, which means you need to define the nodes, you need to define the links, and this can take a lot of time, and it can be error-prone. Just imagine if you have to create 100 VMs and you need to create the connections between all those VMs. Obviously, it takes time, and no one wants to do that manually. So obviously, today, we also have amazing tools like EVNG or GNS3 to do these kind of things. But unfortunately, the learning curve is a bit steep. And especially if you are new to those tools, you're going to take a lot of time trying to figure out how to deploy a certain specific use case, a certain topology. And so this is something we thought could be at least a little bit improved. So at Nokia, a few years ago, we were trying to introduce a new network operating system. And this new NOS was based on a container image. And we were like, OK, we have EVNG, GNS3 to deploy virtual machines. That was at least a few years ago. And we want to provide a tool to help people deploy this new NOS as a container image. And obviously, those topologies, they only make sense if you have multiple nodes. So you cannot just use Docker to deploy a single node. It's going to be a bit useless. So you need to find the proper way, the proper medium to deploy multiple nodes as fast as possible. So we had the following observation. We looked around and we saw that in industry, you have tools like Terraform, Ansible, amazing tools used by a lot of people in this industry, and they have one common point, which is the declarative approach. The declarative approach is going to help you removing a layer of complexity, and it's going to help you, you can share this declarative model easily to your colleagues, and they can reuse it and reproduce the steps on their own. So we wanted to apply this approach to network labs as well. And this is exactly what we've done with this small tool that we called Containerlab. On the left side of the screen here, you can see that we defined a simple topology in a file containing different nodes and different links. So it's as simple as this. You define the topology that you want to deploy in your environments. And once you have this file, you can provide it to this little piece of software called Containerlab, and it will take care of deploying the topology for you. So again, as I was saying, we already have tools to deploy this type of environments, right? So I think a comparison is the fairest thing we can do at this stage, because we already have EVNG and GNS3. As you know, those tools have been there for a very long time, and they have credibility in the industry, right? It's not like it's a very buggy tool. I mean, you can definitely use that to mimic topologies and deploy network labs. They have a UI, which is a very powerful tool, but at the same time, UIs can be also a constraint. So that's something you need to adapt with. And also, Eve and GNG and S3 were developed many years ago, especially around VMs. So nowadays, this is not really the most convenient because, as you know, everyone is moving to containerization. So if we look now at Containerlab, I think you're very smart and you've noticed that Containerlab says container, not VMLab. So Containerlab is focused on a containerized approach. The idea is to deploy only containers to form a topology and to also have this declarative approach. What is the benefits of this? It means that with the single file where you deploy your topology that we have seen on the previous slides, it means you can easily share it with people. You can also host it on GitHub. You can integrate it to a CI/CD pipeline. So if you want to, for example, introduce a change in your topology, you can just push that change to your repository, and then through a CI/CD pipeline, you're going to have pre-checks, post-checks to make sure that this new change is not going to interrupt the functioning of your topology. Obviously, Containerlab is a young tool. It's been there for 3 years now. So, of course, that brings challenges. And one of them is the support for different vendor network operating systems. So let's talk about this. Here on this slide, you can see the different network operating systems supported by Containerlab. You will see the usual suspects, like a lot of vendors, obviously, but also you can see Ixia and so on. And obviously, since this project is open source, the idea is that anyone can contribute. So sure, the list is short, sort of, but if you actually want to use another network operating system, you can reach out to the community to request for such an OS, or you can also work on the tool yourself and introduce this new image on your own. You will notice on this slide, we have 2 types of images. We have container-based images, and we have VM-based images. So that's a bit contradictory with what I just said when I mentioned that Containerlab is only deploying containers, right? Well, the thing is, even though we would love to do everything with containers, we cannot just get rid of all the previous network operating systems running on VMs. That would be nice, sort of, but we just can't do that. So you see, we support 2 types. Container-based NOSes, in this case, means that originally those NOS are based on containers. And for the VM-based network operating systems, we are using a little trick. This trick relies on a GitHub project called VRNetLab. And this project helps you wrap a VM inside a container. This means that eventually the footprint of the container will be exactly the same as the virtual image originally, but it provides the advantage that you can deploy it as a container, and all the other containers part of that topology will not be aware that this is actually a VM running inside a container. So this is the trick you can use to actually run different types of VMs inside a Containerlab topology. Okay, so I'm talking a lot about what this tool can do, but I think it will be much better if you show if you see actually what this tool can do. So here is a few steps that you can achieve with Containerlab, and I will take you through some of those. So you will see quickly how to install Containerlab, how to create a topology file, how to deploy this topology, and then how to access the nodes. And eventually, if you want to, you can also save this configuration to share it later on to other people. So let's move on. And in this case, I'm going to take the following example. This is a dummy example, so please, people from IXP, don't kill me. But this is the topology I'm going to use. 2 peer routers at the bottom, and then 2 route servers at the top, both having eBGP sessions to share routes between them. So the first step that we want to achieve, first of all, if we are new to Containerlab, well, we need to install it, right? And in opposite to some other applications, Containerlab is very simple to install. And it's supported on Linux, on Windows with WSL2, and also on macOS, provided that you have a Linux container image running. So it doesn't really matter which network, which OS you're using on your laptop. You can run Containerlab on it, and then the footprint it's going to occupy at the end will only depend on the VMs that you deploy at the end of the day. So Containerlab is just going to run for a few seconds to deploy the VMs, and after that, it will be gone and it will be quiet. Yeah, so if you want to have a look, all the install procedures are described at this URL. There will be a QR code at the end of this presentation, so if you would just want to bear with me for the next couple slides. Once we have Containerlab installed, what we want to do really is try and start to write this topology file. So this is crucial. This is the core of Containerlab, really, because it's going to help you in a very powerful way. It's going to help you to define this topology. So you see multiple fields. You have the name, which will be used to assign a name to the containers created in this topology. And then we have topology nodes. And in this nodes section, we are going to define all the nodes part of our topology. So on this slide, you see we have only one node on the right side. The name is called peer1. And in the topology file, we have to define this node, peer1, with the same name. You have three fields. The first one is kind. So the kind is related to the type of network operating system that you want to deploy. So in this case, we want to deploy SROS. You also have to provide the image that will be deployed on the node. So of course, the image can change depending on the version you're going to use and so on and so on. This image has to be provided by the user. So if you don't have this image and it is not publicly accessible, Containerlab will not be able to process. If on the other side, the image is not available locally, but it is actually available online, Containerlab will rely on Docker to retrieve this image and to deploy it in the topology. So it means if you install a new topology for Containerlab, you just have to run the commands to deploy this topology, and Containerlab in the background will take care of doing this annoying job of retrieving manually all the images. The last field on this slide is the license field. So this is specific to the network operating system you're going to use. Some of them require a license, some others don't. In this case, we need a license, so you can also specify this license in the topology file directly. Again, the license needs to be provided by the user, and is not provided by Containerlab. So fast forward, we are going to deploy to define our other nodes. So let's move on with peer2. In this case, we use FR routing, so that's a Linux kind in this case. And we do the same with the route servers. So one by one, we see that we have OpenBGPD and then Bird for our second route server. So that's a start. We have 4 nodes in this case, but there is a missing piece, obviously. And this is the connectivity between all those nodes. So in this specific case, what we want to do is use a peering LAN, which will be represented by a Linux bridge. In this example, the Linux bridge has already been created by the user on the machine. So this is mandatory in this case. You cannot just rely on Containerlab to do that. But once the bridge is created, Containerlab will use it and can use it in the topology. So we have our 4 nodes, we have our peering LAN. The last thing to do now is to add the links. So let's do that. And for this, we need a new section, the links section. We are going to define every link as an endpoint, as a pair of endpoints. And you will see that to refer to some of those nodes, we need to give the name of the nodes and then the name of the interface. The name of the interface will depend on the network operating system that you use. There is a syntax for this available on Containerlab website. And you will see that we have our first endpoint for SROS and then our second endpoint for the Linux bridge itself. Eventually, you do this for every link. And once you have this list established, all your links will be created once you execute this topology. Just before we do that, I want to take you through the connectivity behind Containerlab. So, because everything looks magical and perfect, yeah, you just have a topology file and everything happens magically, but obviously there is something real behind. And the reality here, it's another example in this case. You see we have a topology with 2 nodes, and those 2 nodes are linked through a single interface. You will see here that those 2 nodes each have, after being deployed, each have their own network namespace. So as you can see, the interfaces are created in each of those namespaces, and they are linked to the proper endpoints. So if you look at Ethernet 1.1, it goes from SRL1 to SRL2. But another point is that even though we haven't specified them in the topology file, we also have access to management links. Those management links will be created by default, and obviously you need them because you want to access those nodes at the end of the day. You want to SSH to them, or you want those nodes to communicate maybe with other applications. Let's say, for example, you want to deploy a telemetry stack. Well, you will typically use the management interface to access those nodes. So those management interfaces are really useful and relevant in this case. And they are directly connected to the Docker network that you can see in the default namespace. All right, so let's deploy this. To deploy a topology, 1 single line command, Containerlab deploy, and then you provide the topology file that you want to deploy. And you will end up, in a matter of seconds, with a list of all the different containers part of that topology with a very short summary. So you have the name for each of those containers, you have the container ID, the image, the kind, and at the end, you also have the IP management address. This is a really nice summary, but one extra thing that you don't see is that Containerlab is also populating the host file on your machine, creating the mapping between the name of the container and the IP address used for management. Meaning that if you redeploy this topology multiple times, maybe the management IP address is going to change. And obviously, it's going to be a bit confusing if you used, I don't know, the first IP address to reach out SRS, but then it ends up being assigned to the route server number 2. So the idea is that you reach those nodes only using the host name populated in the host file. And you can do this with the following example. So provided that your network operating system supports SSH, you will be able to access the node via SSH. And if not, let's say you have a standard Linux image that you want to deploy, and SSH is not enabled by default. Well, in this case, you can simply use Docker exec to execute a shell directly on the node. So this is the really basic scenario that you can execute. Obviously, Containerlab provides many other options. In this case, we started from a topology without any pre-configured state. In this case, you can also specify a startup configuration if you want to. So again, that's very useful. If you want to share this configuration to a colleague, you say, oh, look, I have this issue in my topology. I have that configuration. Can you have a look? And instead of giving access to your colleague to a very well-isolated VM or environment, then you can just share this topology file with the configuration file needed, and he will be able to replicate it very easily. On top of that, you can also bind volumes between the hypervisor and each container. So that's exactly the same way Docker does it, if you think about it. And you can also execute commands at boot up. So let's say you have a Linux container, you want to assign an IP address at boot up. Well, you can do that actually with the exec field. So this IXP lab that I just showed you on the slides is actually not just an example on slides. It's also available online, and you can go through all those different scenarios. So the Containerlab website contains a lot of examples, a lot of different topologies. so that you can immediately start playing with those if you want to. So here is a QR code where you can access directly this IXP lab. You have a small tutorial taking you step by step through the different activities in this lab. And so feel free to have a look. That's quite interesting, and it helps you get familiar with Containerlab. As I was saying, I'm only scratching the surface here for the sake of time. But just know that you can also do traffic capture with Containerlab. You can use Wireshark. Since those containers are deployed in a Linux environment, you can use and leverage those interfaces in each network namespace to capture traffic successfully. At the same time, you can also add link impairments if you want to. So if you want to do some tests related to convergence, you want to have your topology as close as your real environment, of course. And you can do that by adding some delays and latency and packet losses all around the topology. So that's it for me. I'm just going to close this presentation by letting you know that Containerlab is fully available through this website, containerlab.dev. You can also have a look at the open source project called, on srllab/containerlab on GitHub. And at the end of the day, if you have more questions, if you need help to get familiar with Containerlab, well, you can always access the Discord server on which we have a lot of different people from different companies. So let's say you have questions related to a specific vendor NOS. Well, you will definitely find some people from that company trying to help you set up your environments. So feel free to get interested, to get engaged if you want to. And I hope this had your attention. Thank you very much.